So continuing on with geometry, we talked about angles to start this unit off with. This one is a pretty lengthy one, because we're going to talk about polygons very briefly, and then we're going to start talking about special types of polygons, four-sided ones and three-sided ones as well later on in the unit. So what's a polygon? Well, you see four examples there, okay? It's made up of sides, but the shape has to be closed. Okay, so for example, this would not be a polygon because it's not a closed shape. Okay, all of these are closed. So not a polygon. Two types of polygons we can look at. Like I said, I'm going to go through this fairly quickly, this first part. Regular and irregular. Pretty straightforward. A regular polygon, all the sides are the same length. Irregular, all the sides are not the same. So, regular or irregular? Come on. Regular or irregular? Regular. All the sides are the same length. Regular or irregular? Irregular. How about this one? Regular. Not only if all it's going to be the same length, so are all the angles inside. So that's another way you can tell. This you're not given the sides, but you are given the angles. Are the angles all the same? Right. They're not all the same, which means the sides are not going to be all the same, which means we're talking about irregular. Okay. And then finally, just a general talk about polygons. You should be familiar with most of these. Okay. The names that we give to the number of sides of polygon. And we're going to focus on quadrilaterals today and then eventually triangles. Okay. So quadrilaterals, as you can see from the table, it is a four-sided polygon. And there are many different types of shapes it can take, a four-sided polygon. And depending on the shape the quadrilateral takes, we give it specific names. So for example, this one here is a quadrilateral. It's not any kind of specific shape. You can't really say anything about the sides or the angles, nothing yet. Okay, so it's just kind of a general quadrilateral. Some things that you should know, okay? How do we name quadrilaterals? Well, we use capital letters to name the corners. And another word for the corners, or where two sides meet, is called a vertex. And many of them are called vertices. And usually when we name a quadrilateral, we do so in a clockwise or counterclockwise order. So start, so if we had something like this, and I wanted to call it WXYZ, I would pick any corner, W, and then I'd start going around clockwise or counterclockwise, doesn't matter. And just put the other three letters. Okay? A couple other words you should be familiar with quadrilaterals. If we have two angles that follow each other in order, or they share the same side, Okay, so angle C here and angle B here share this same side. We call those consecutive angles. If they don't share the same side, they will be opposite to each other. Okay, so you should be familiar with opposite and consecutive sides and angles, well, consecutive angles and opposite angles in a quadrilateral. General property about quadrilaterals. I can take any quadrilateral, connect two opposite corners, and I will always form two triangles. So if I connected D with the opposite B, I've made two triangles. Or if I decided to do C, connect C and A, I've still made two triangles. Okay. What is the sum of all three angles in a triangle? 180 degrees. Okay. So if we take this one, we know that these three angles have a sum of 180 degrees. We know these three angles have a sum of 180 degrees. If we put them together, all the angles in the quadrilateral will have a sum of 360. Okay. So knowing that, because remember, so in a triangle, the sum of all three angles is 180. In a quadrilateral, the sum of all four angles is 360. So knowing that, we can answer this question. How would you find the missing angle in this quadrilateral if you're given the other three? Yeah, 360 minus all of these. Or you can add these up, subtract from 360, either one. So we just do 360, take away the 68 degree one, take away the 126 degree one, take away the 106 degree one, and we will get an answer of 60 degrees. Okay, certain types of quadrilaterals. And we're going to look at 5. They're all called quadrilaterals, but because they have some special properties, we give them specific names. And the first one, and you're familiar with, I believe, all of these, well, a few of them absolutely. A rectangle. What can you tell me about the opposite sides of a rectangle? They're the same. They're equal. What else could you tell me about the opposite sides? Not the sides.
Only two of the sides are the same?
What's that?
Only two sides
Yes, you're right. So it's got two pairs of equal sides, but they're different from each other. Not only are they equal, they are
Great. Long. Long. Great. Horizontal.
as opposed to
Slant.
if they run the same direction, they never meet. Parallel. Sorry, I probably didn't mime that very well. And then, what can you tell me about all four angles?
They're equal and
They're all equal and they measure, what's the measure of each one? 9 degrees. Yep. So if you look at this diagram here of a rectangle, the single notches tell us the opposite sides are the same, and the double notches tell us these opposite sides are the same. The little squares, you should be familiar with, that means 90 degrees. What we could have added to this are little arrows, and I will add them. If you've got little arrowheads on the sides, that's meaning whether they're parallel or not. Okay. A rhombus. What can we say about the opposite sides of a rhombus? They're equal. What else are they? We just talked about it.
Parallel.
Parallel. Okay. So I'm going to add that. So the opposite sides are parallel. I'm not going to say the opposite sides are equal because in a rhombus, all of them are. So we would say all sides are equal. What can you tell me about the opposite angles in a rhombus? They're not 90, obviously. They're the same. So angle D and angle B are the same measure. Angle C and angle A are the same measure, but different from D and B. So the opposite angles are equal. Then if you took a rhombus and if you bent it up so that it was all 90-degree angles, you get a square. And square is pretty obvious. Opposite sides are parallel, same as rhombus. All sides are equal, same as rhombus. But the interior angles now become all the same, and they all measure 90 degrees. So again, we can do the notches, the arrowheads for showing the opposite sides are parallel. Parallelogram. That's like taking a rectangle and bending it. Right? And here we can see we've got the arrowheads here. So like a rectangle, the opposite sides, not only are they parallel, but they're also the same. So opposite sides are equal, opposite sides are parallel. What about the opposite angles? They're not all 90 degrees, but they equal to each other. So you can see each of these shapes has sort of slightly different properties. That's why we give them distinct names. Okay, trapezoid. That's the fifth one. And we can have a couple of different looking trapezoids. One like this and one like this. Both of these are trapezoids. What can you tell me about one pair of sides in a trapezoid? They're what? They're parallel. So in any trapezoid, one pair of sides is always going to be parallel. Always. But there is a special type of trapezoid where one pair of sides is parallel, but the other two sides are the same. Okay, and in that case, we call it an isosceles trapezoid because one pair of sides is equal. You can see down here. I mean, it's very similar to an isosceles triangle. In an isosceles triangle, two sides are equal. In an isosceles trapezoid, two sides are equal, the other sides are parallel. Okay? If these two sides are equal, the angles on the bottom are also equal. Okay? They're also going to be the same measure. So how do I say this? I want to make sure. I'll call it the base angles. That's what I call them in the diagram. Actually, I should have put one pair parallel there, but so we can take this out. Just remember that an isosceles trapezoid has three properties. One pair of sides is parallel, or sorry, opposite sides are, one pair of opposite sides are parallel, one set of opposite sides are equal, and the base angles are equal. Okay? So knowing that, knowing those five, let's try to answer these questions. Which of the five quadrilaterals all have equal sides? Square? Anything else? No, rectangle doesn't have all equal sides. There's another one.
Oh, the rhombus.
Rhombus. Square. Rhombus. Which quadrilaterals have all the angles 90 degrees?
Square.
Rectangle and square. Which quadrilaterals have opposite sides that are parallel? Yes. What else?
Rhombus.
Rhombus. What else? There's a rectangle on the opposite sides parallel? Yeah. Square?
Yeah.
Yeah. Trapezoid? Only one pair, right? Not both pairs. So we stop there. Which quadrilaterals have opposite sides that are equal? Would you agree it's all four of these again? Opposite sides equal? Yeah. So I'm just gonna say, instead of having to write them all over again. And what quadrilaterals have opposite angles that are equal?
All of it.
All of them again. The only one that doesn't meet these are trapezoids. There are some other properties we're going to look at with quadrilaterals. And one such property are diagonals. How do you draw a diagonal inside of quadrilateral? You pick one side, one corner, and go to the opposite corner. So in this one, how would we name the diagonals? What's one of the diagonals? How would you name it? DB. You said CA.
Yeah.
Yeah. That's it. So let's revisit. The special types of quadrilaterals and draw diagonals and see how they relate to each other. So if I draw a square, the diagonals in the square, equal or no? Yep. Rectangle. Yes, again. Rhombus. What's that? Rhombus? Look at the diagonals. Do they look the same way?
No.
Right, not equal. If they're at 90 degrees, they're going to be equal. But if they're not at 90 degrees, looks like they're going to be non-equal. So that's not equal. Trapezoid, not equal. But what about an isosceles trapezoid? Equal. So square, rectangle, isosceles, trapezoid have equal diagonals. You don't really have to know so much all the properties of it. You're just going to have to, I mean, you have to know the properties. But you're not going to be given questions where it's just like, okay, list this about this quadrilateral, list this about this quadrilateral. You're going to be given problems that we'll talk about. Okay, diagonals, they meet each other. They cut across each other, don't they? Inside the polygon or inside the quadrilateral. If they bisect each other, that means they split each other into two equal parts. Okay? So for example, if we look at this rectangle, we know, or we should know, rectangle. We should know that AC is equal to BD. But they split each other in such a way that all the segments that are made are the same. That means they're mutually bisecting. To bisect means to split into two equal parts. Okay? And notice here, it includes not just rectangles, rhombuses, squares, and parallelograms. Their diagonals all split each other into equal parts. Okay. So In the first one, we have a square. We are told half the length of this diagonal and half the length of this diagonal. You are asked, what is the length? Oops. And what's the length of AC? What would it be? Yeah. If this is 3, this section is also 3 because they split each other into equal segments. So this must be 3, which means that AC must be 6 centimeters. What's BD? 6 for the same reason. Right? If this is 3, this section must also be 3. Or it has to be the same length as the other diagonal. So BD is 6 centimeters. This one is actually, if you sort of tilt your head, it's a rhombus. But the way that it's oriented, it looks almost like a kite. Okay? We're told that this is 4 and this is 2. What's the length of FH? 8. Because if this is 4, we know the diagonals split each other into equal segments. This must be 4. And what's IG? 4. This is 2, this must be 2, which together make 4. So these are the kind of questions. One more thing about diagonals. Most diagonals in 4 shapes that we talked about, 4 quadrilaterals, they cut each other into equal parts. Sometimes they cut each other at 90-degree angles. That happens in 2 cases. Okay? Squares and rhombuses. Not only do they split each other into 2 equal segments, they split each other at 90 degrees. So here, in this square, these are the same, these are all the same, equal sides, but these are all 90 degrees. So, knowing that, here we have a rhombus. You can tell because it's slanted. It's just like a slanted square. What are the measures of all 4 angles inside? A lot of times you can just look at them and tell. What measure do they look like? "90 degrees. All are 90 degrees. So let's sum up these diagonals. Because we talked about whether they are mutually bisecting, we talked about whether they're perpendicular, and if obviously they're mutually bisecting and perpendicular, that means they're both. So a square, do they split each other into equal parts? Yes. Check. Do they meet at 90-degree angles? Yes. Which means it has to be this too. A rectangle, do they split each other into equal parts? Yes. Do they split each other at 90-degree angles? No. Right? Which means that it can't be both. Rhombus. Well, again, it's going to look like this. Do they split each other in equal parts? A rhombus? Yes. Do they split each other at 90-degree angles? Yes, they do. Rhombus and squares. They cut each other like here. Look at this. There's a rhombus up here. Notice how they cut each other at 90-degree angles. Only squares and rhombuses do that. Oh, I don't know why it just keeps drawing these things. Drives me crazy. So a rhombus, like a square, cut each other into equal segments, cut each other at 90-degree angles, which means they have to be both. Parallelograms are like rectangles. Yes, they split each other into equal segments, but they don't cut each other at 90 degrees. Trapezoids do none of them. Even isosceles trapezoids do none of them. The diagonals in an isosceles trapezoid are the same, but they don't cut each other into equal segments. One final thing to look at. And we're going to go back to polygons, not just quadrilaterals. How many diagonals can you draw in a certain sided polygon? 3. So in this one, I can draw 3. Would that be 1? Would that be 1? Would that be 1? Are there any others? Where? You go straight down. Okay. You can go straight down. You can go like this. Yeah. Like that. Like that. Like that. So you can draw several diagonals. Okay. As long as it goes to a side that's not consecutive. So like if I did a pentagon, easier way to do it, if I did say a pentagon.
That is the most grabbing.
All right. Obviously I can't draw a diagonal there, but I could draw one here, here, and that's it. If I go to this side, I can go here, here, and that's it. If I go to this corner, I can draw here, and it looks like that's it for all of them. All the diagonals. So the question is, how many diagonals can I draw? Well, in this one, I was able to draw 3, 6. Oh, how do I do this? I'm gonna have to do it again. 1, 2, 3, 4, 5, 6. Already did that one. 7, 8. Already did that one and that one. 9. I was able to draw 9 diagonals. Yeah, I should be clear, like when we talk about diagonals in a quadrilateral, they go from one opposite corner to another. But in any polygon besides a quadrilateral, so like pentagon, hexagon, heptagon, etc., as long as you're not drawing to a consecutive angle, it's a diagonal. So this one would be, how many did we do? 1, 2, 3, 4, 5. Did I get 5? 1, 2, 3. Yeah. Okay. Obviously, you can see that's a little bit, trying to keep track of it might be a little bit challenging. There is a formula that we can calculate the number of diagonals. Okay? And the formula is, and you're given this on the formula sheet. Okay? It is the number of sides times the number of sides minus 3 divided by 2, where n equals the number of sides. And like I said, this is formula sheet.
Like, should we add a restriction, like it has to be greater or equal to 3?
Yes. Yeah, obviously it has to be. You're right. Okay. But technically, yes, we should. N has to be, yeah, oh, okay. N has to be greater than or equal to, or sorry, greater than 3.
I think it can be like 3 because it's.
Well, no, that would give you, oh, yeah, 0 diagonals, yeah, right. It's 3, yeah, triangle is a polygon. So how would you do 8 sides? Pretty straightforward. Just go 8 times 8 minus 3, divide 2. That gives us 8 times 5 divided 2, which gives us 20 diagonals. Okay. No questions, actually. Okay, it's started playing YouTube here. So I got to shut that off. There we go. Okay. What if I said this? Okay, it's square. And I told you that this length was 5 centimeters. What's that length?
10.
Good. Okay. What's this angle?
90.
If it's a square, 90 degrees. Okay. If I said this, oh my. Every time I touch it, it starts again. It's to stop that. Okay, this one. What's X?
Oh, yeah.
You have to know this. Well, what can you tell me about these two sides, or these two segments? They're equal. So 2x equals 12. Therefore, x equals 6. Be surprised to see questions like this. Okay, one more. This is a challenging one. This is a rhombus. Okay. This side, this whole diagonal, is 6. This whole diagonal is 8. What's the length of that side? 5. Whoa! How'd you get that?
You can just like divide by 2 will also go and like 3 5. It's like
Correct.
perfect.
Okay, so watch, follow along here. So this is, I'll use a different color. No, it's not let me use that color. I'll use black. So, what's this length? 3. What's this length? Because it's half of 8. What can you tell me about this angle? So therefore, how do we find it? We have to use Pythagoras. So 3 squared plus 4 squared is equal to, let's just call it x squared. That means 25 is equal to x squared. X is 5 centimeters. Or if you just recognize it as a triple, that's fine. Okay? So you're going to have to be familiar with ones like this, how to do them, which is why it's going to be important to do the practice questions in the exercise, because many of them are like this. Okay? And the next assessment is not a hand-in assignment, it's a test. So you're going to have to know this stuff. Okay.